Good morning to all. Today we are getting started with the topic. Topic is derivation of law of conservation of linear momentum from Newton's third law of motion. So let's start. Consider two bodies A and B, masses m1 and m2, constituting an isolated system. Let the bodies are moving with velocities u1 vector and u2 vector. u1 vector is more than u2 vector. After collision, let these bodies move with velocities v1 vector and v2 in the same direction. So this is u1 and u2. This is m1 and m2. This is before collision. This is during collision, and this is after collision. So these are the forces acting FAB, force on A because of B, and this is FBA, force on B because of A. So let's start. Total momentum before collision is equal to m1 u1 vector plus m2 u2 vector, and total momentum after collision m1 v1 vector plus m2 v2 vector. So change in momentum of the body A after collision is m1 v1 vector minus m1 u1 vector. So change in momentum of body B after collision m2 v2 vector minus m2 u2 vector. So during the collision, let the body B exert force FAB vector on the body B such that by Newton's third law of motion FBA equal to minus of FAB. Let this equation be third. If delta t be the time for which the collision take place, then the impulse of force acting on A equal to F vector AB into delta t. Similarly, the impulse of force acting on B equal to FB vector into delta t, and since impulse equal to change in momentum, therefore body A F vector AB into delta t equal to m1 v1 vector minus m1 u1 vector, and for body B FBA vector delta t equal to m2 v2 vector minus m2 u2 vector. Substituting these values in equation 3, we get m1 u1 vector plus m2 u2 vector equal to m1 v1 vector plus m2 v2 vector. It means momentum of an isolated system before collision equal to momentum of isolated system after collision. This law of conservation of linear momentum. If the